problems. Just give me a second. I'll just quickly come back to your questions. But before that, let me know if you guys can hear me well. If I'm audible properly, uh, or if I'm not audible, can you guys quickly let me know if I'm audible or not? So, yes, you guys can hear me. Awesome. So, I'll quickly read through your questions. First question is, why do you not upload solution of the problems of jobathon? Uh, I'm not responsible for jobathon. I think someone else had taken the stream. Not sure why the solution is not uploaded. What I can do is I can check for you, like why was it not uploaded. Hello sir, can you please share the playlist link for interview series? For interview series, I'm not sure if there is a playlist. If you can check the channel if there is one. Otherwise, you can just look into the videos and try figuring it out. I believe that there should be a playlist. So if not, I'll try to get it done. Right? I'll try to tell the team to get it done. I think that works. Any other questions or doubts that you have before we start with today's class? I don't think we have. Probably don't have a playlist for. All right. What was the last question about? Did not get it. I'll discuss that. Don't worry. We'll go again. We'll go step by step. First problem, second problem, then third problem. That way. All right. Let's start with the problems without wasting time, because I think quite a few of you are here. We'll not wait for others to join. Like while they join, they can just rewatch the thing. So let's start with the first problem. So finding the non-zero digit. I'm pretty sure that accuracy is 6.44%. Oh wow. All right. The the accuracy is 6.44%. All right, let's see. So Alexa is fond of mathematics. She is solving a maths problem in which she is given an array ARR of n integers, and she has to find the rightmost. I think that was from DP. The last problem. What was the last problem? This was our binary search problem. So I'll discuss about that, like how to do that. But it was the binary search. So Alexa is fond of mathematics. She is solving a maths problem in which is given an array ARR of n integers, and she has to find the rightmost non-zero digit of the resultant number, formed after multiplying all the elements of the array. If there is no rightmost non-zero digit, then return -1. Okay. If there is no rightmost non-zero digit, then return -1. Cool. So what is it given to us? It is given to us that we have to multiply all the numbers, and whatever is the rightmost non-zero digit, we have to return that. Otherwise, we have to return -1 if there is none of them. So for example, 3, 23, 30, 45. What is the rightmost non-digit? So after multiplying, then we get 91350, right? 91350. So the rightmost non-zero digit is 5, right? So we'll return 5 here. Similarly, for these 1, 2, 3, 4, 5, the sum will be 5 into 6 by 2. That is okay, n into 1, 2, 3, 4, 5. 5. Okay, it's multiplied, right? 5, 4, 20, 23, 120. So 120, the rightmost non-zero will be 2, right? So that is the question. Now, how do we solve this, right? How do we solve this? Let's understand that. So if you think carefully, right, what exactly is the rightmost last digit? So the rightmost last digit will generally be made up, will always be made up of the right last digits of all the numbers. Like let's say we have 23 and 32. These 3 and 2 would not contribute to the last rightmost last non-zero digit, but this 3 and this 2 will be contributing to the rightmost last non-zero digit, right? So that's basically what is the rightmost last non-zero digit. Again, like these also might contribute, right? These also might contribute, but it will always contribute when it is something of the form like 20 into 30. In these cases it will contribute, like these digits will start contributing. Otherwise, if there is something, right, if there is something like here, let's say a 32 comes in, so this 2 will be contributing to the rightmost one. So if we like look into what is the product, so it will be 30 into 20 will be 600 into 32, so that will be 600 into 34, 12, 6 2s are 12 something, right? So it will be ending with 2 or something like that. So anyways, that's basically the idea. Or rather, what we can think about here is that what we can do here, let's understand how do we get the rightmost digit. So first is 3, 23, 30, 45. 323. What essentially do we mean by rightmost last non-zero digit? So let's say we have 323, 30, 45. What essentially do we mean? We mean to get the rightmost digit. To get the rightmost digit, what do we mean? We mean modulo 10, right? So that will return the digit at the first place, but again, like that might be 0. So we want a non-zero place. So first thing that we'll do is we'll get rid of all possible zeros, right? How do we get a 0? We get a 0 from a 5 and a 2. We get a 0 from a 5 and a 2. So 5 into 2 will be 10. So that's why we get a that's how we get a 0, right? So first thing that we should do is we should remove all occurrences of 0, right? So first thing, how to remove them? We'll remove all occurrences of 5 and 2 and we'll treat them separately, right? If there is an imbalance. So 3, nothing, no 5 is there. 23, no 5 is there. 30, 30 is basically 3 into 10, that is 3 into 5 into 2, so it will become 3. We'll get rid of 5 into 2. So let's say count of 5 equals to 1, count of 2 equals to 1, right? 45, 9 into 5 is 45, so count of 5 will be 2 and this will become 9. Now we are doing a modulo 10. Now in this we are able to get the rightmost the last digit here. That might be the rightmost last digit, but again, like these 5 and 2 has been removed, so there might be some imbalance. Like for example, here there are 2 5s with us, right? And here there is 1 2. So 1 5 into 2 will be pairing up to 10, so we'll get a 1 0 here. But the remaining 5, it is not paired with a 2, so that will not actually give us 0, right? So we have to consider that as well. So how do we do this? Now to do this, we know that from modular arithmetic, a into b, modular arithmetic a into b modulo c, we can write it as a modulo c into b modulo c whole modulo c, right? We can write it like this. So what we can do is 3 modulo 10, we can modulo all the independent elements. 23 modulo 10, 3 modulo 10, 9 modulo 10, right? So 3 modulo 10 will be 3, 23 modulo 10 will be 3, 3 modulo 10 will be 3, 9 modulo 10 will be 9. So what is the output here? 9 into 3 into 3 into 3. So 9 into 9, 81, 81 into 3, I think 273, 273, 273, right? We get 273, but is 3 the last place? No, because we have an extra 5 here, so we have to include that as well. 273, and again modulo 10 will do, so that will give us 3. 3 into 5, that is 15. 15 modulo 10 will be 5. So the rightmost non-zero digit will be 5, which is actually true, right? Which is actually true, which is indeed 5. So this is the logic that we'll use. Let's actually run through another example just to understand better. Let's just run through another example, right? So first thing that we'll do is we'll get rid of the possible zeros, right? We'll get rid of possible zeros so that we get something that is non-zero, and then we can bring back the imbalance factors, right? So let's do another example. Let's come here. So 1 2 3 4 5. 1 into 2 into 3 into 4 into 5. Now what we'll do again, we'll do the same thing. First is we'll get rid of 2s and 5s. So count of 5 will be equals to 1 and this will be reduced to 1. Count of 2 will be equals to 1. That is 1, 2. And this will be reduced to 1. Achha, coming to this part, are you clear about this? Like, let's say we have 5 into 3 as one number, that is 15. And let's say we have 2 into 3 as another number, that is 6. So when we do 15 into 6, this basically means 3 into 3 into 10, right? The same thing. Because we can club this 5 and this 2 into like together. So that will mean the same thing. That's why we can pull it out like without affecting the answer. So now we will do this modulo 10. We'll find this modulo 10. So modulo 10, 1 will be 1. 3 into 4, that is 12. 12 modulo 10 will be what? 2. So 2, and this is balanced because 1, 5, 1, 2 will give us 0. So this will become 2, right? So the answer will be 2 for this, and it is indeed 2. So this is how we can solve this problem. Let's look into the code for this. Let me know if you have any doubts or anyone has any doubts on this. Let me know if you have any doubts on this. All right. Count 5 equals to 0. Count 2 equals to 0. Right. Count 5 equals to 0. Count 2 equals to 0. So for what we'll do is first we will get rid of all 5s and 2s. So for int I equals to 0, I less than arr or n, I plus plus, while arr I modulo 5, it is divisible by 5, is equals to 0. arr I will remove that 5, so divided by equals to 5 and count of 5 plus plus. Similarly, while arr of I modulo 2 is equals to 0, we'll do arr I divided by equals to 2 and count of 2 plus plus, right? So we are done reducing. Also, we maintain the result here, int res equals to 0, res equals to res into arr I modulo 10, right? So res equals to 1, res equals to 1, and res equals to res into arr I modulo 10, right? Now when can it be minus 1? That's something that we've missed. When can it be minus 1? It can be minus 1 only when everything is 0, right? All the elements are 0. So let's check that as a con, or if there is only one, if there is 1 0, then the entire result will be 0. So if there is 1 0, then it is minus 1. So let's do that separately. So is 0 there equals to false initially. So for int I equals to 0, or what we can do is 0 there. All right, let's do it here only. So res equals to res into arr I modulo 10. So if there is a 0, this will become 0, res will become 0. So we can do it here, that if res equals to 0, then return a minus 1. Otherwise, what we'll do is int minimum, we'll take the minimum of count, min TNT will be the minimum of count 5 and count 2, because that many zeros will come in. So minimum of count 5 and count 2, that many zeros will come in. Count 5 minus equals to min count. Count 2 minus equals to min count, right? So we are done with this. Now if count 5 is greater than 0, right, then we will do res equals to res into 5 modulo 10. Similarly, if count 2, one of them can be greater than 0, one of them, but both of them will not be greater than 0, because if they're greater than 0, so their min count would have been like, one of them min count will be either count 5 or count 2, the minimum of them, right? So one of them will become 0. So in that case, res equals to res into 2 modulo 10, and finally return res. So let's run this and see if this is working. Okay, this is, I think, working. So let's try to submit. it is going into time limit exceeded. Why is it going to time limit exceeded? Let me just quickly check. So pi equals to 5 divided by equals to 5, and what I can do is I can optimize a bit here. Listen to it. If res greater than 10, greater than 10, it cannot be 10, right? So greater than 10, so res mod equals to, so we can do this much optimization. Return any other optimization that we can do. I equals to 0, I less than n, I plus plus, while arr I, that is the expected complexity, I believe, n log max of arr, right? So we are going to log of max of arr only, but modulo can be expensive, so we can do this much optimization. Still taking a lot of time. Vector in arr in count 5 equals to 0, count 2 equals to less 1, while arr I modulo 5 equals to 0, while it is there. So arr I divided by 2 can actually do right shift 1, if that helps. Which side should we? I think this is this. It is right. Check if arr I equals to 0. Yeah, we can do that. Like we can check at any point. So if this equals to 0, then might it take it here. So any point it is becomes 0, we can break it. Try to submit it. It's still a time limit. Count plus plus. Am I missing some loop? 5. While arr, oh, okay. If it is 0, then it will go into a infinite loop, right? If it is 0, then it will go into a infinite loop. So if arr I equals to 0, it will go into an infinite loop, right? Because it will be divisible by 5. So we will just make res equals to 0 and break. Yeah, bad miss. 1 2 3 4 5, your code's output is 6. Okay, that's fine, that I can debug. So 1 2 3 4 5, your code's output is 6. Why is it 6? If arr I is 0, are we doing a proper? Let me just do by equals to, let's see, 5 1 2. I should have run my input on my own. By equals to, am I right? Yes, right. John, I understood. Yeah, it was just run this again. Count to plus plus. It is still giving 6. Let's see why it is giving. So arr I 5 res is 0 and break, and then res 0 return 1. Okay, for while arr I modulo 5 equals to 0, arr I divided by equals to 5, count 5 plus plus. While arr I modulo 2 equals to 0, arr I divided by equals to 2, count 2 plus plus. Res equals to res into arr I, and let's do a modulo 10 here. I believe which, if although that was, I think this this equals to 0. Now we come back to this part. Count 5 minus equals to min count. Count 2 minus equals to min count. Okay, that should, both of them should be 0. Count 5 should be 0. Count 2 should. So it should not come here at all. So try to run. Count 5 equals to 0. Okay, we are still going into 6. So let's add some debug statements, right? So cout press endl, and here let's do something like this: cout arr I what is it that we are multiplying, right? And see out. Let's add some debug state. Try to error I. So 113 4 is removed. Oh, 4 is removed. All right, 4 is removed here. Makes sense. 2 into 2, so 4 3 12. We get 3 out of this, right? This is 3 right now. Min count, let's print our min count here. See out count 5 count. So count 2 should be greater, right? So count 2 and count 5. Count 2 and count 5 should be uh, there. Okay, count 2 is 2, that's fine. So we'll do 2 into 2, and not if, actually it should be while. Correct. So it should be while count 2 greater than equal to 0, count 2 minus, and while count 5 greater than, right? So while count 5 greater than 0, count 5. So that should be it. Now I think we should be okay. Let's just do these things, and 5 count. Let's just run this on this first, and uh, return first non-zero digit in the last. How would you return the first? It would if you see the array elements are within, like it will exceed the integer limit, right? It will exceed the integer limit. We have to, if you multiply like that, it will exceed the integer limit. So this is actually working. All right, let's go to the next problem. I hope you understand, right? Like if there are 10 to the power 5 elements left, right? There are 10 to the power 5 elements, and all the elements are within the range 10 to the power 5. So just think like what will be the two, like if you multiply all of them, what will be the result? It will definitely not fit in integer or long. Let's go to the next problem. So this problem I believe many of you have solved. TLE, it might be because of okay, really, then you only corrected me, right, on count 5 and count 2. So I don't think I've missed that. I'm not sure then why should it be TL. Maybe you can check for cases like where it can run in, but this should work. So let's come to the next problem. There are n rows in the walls of Geeksland. The king of Geeksland ordered Alexa to color the walls on the occasion of New Year. Alexa can color the wall with either pink, black, or yellow. The cost associated with coloring the wall will be color represented by 2D array, colors 3, where colors I0, colors I1, colors I2 represent the cost of painting it in pink, black, and yellow, right? So you have to find the minimum cost of painting all the walls such that no two adjacent walls will have the same color. So this is a pretty simple problem, right? Like I am pretty sure that you must have seen a similar problem somewhere. It's very common that you have to minimize some cost, but you cannot take two adjacent things to be same, right? Like it is very similar to the problem. Let's say you have added a of n elements, and you have to choose the maximum value, and you also have like type as well, let's say, but you cannot choose two consecutive elements of same type, or you cannot choose two consecutive elements or something like that. So I'm pretty sure that you have seen a problem, similar problem in sometime before this. So this is also a same problem, and whenever it is like minimizing something, maximizing something, and you are given some constraint that you cannot take adjacent elements or something, just blindly go with DP, right? It's a standard DP, exactly. It's a standard DP solution. So how do we do this? Let's actually identify the DP recurrence. So let's say if n and type, if n and type, so this will be if n and type will be what it will be, minimum cost to paint all walls, right? Minimum cost to paint all walls if we paint nth wall with color type. Minimum cost to paint all walls if we paint the nth wall with the color that is given by type. That is, if n0, it will mean that what is the minimum cost to paint the first, sorry, not all walls, but the first n walls. First n walls, right? So minimum cost to paint the first n walls, provided I'm painting, like I have n walls in front of me, right? I have n walls in front of me. This is the nth wall. I am painting this wall with a yellow color, let's say 0. Or if n1, this will mean that I have n walls in front of me. I am painting the last wall with some other color like green or whatever is 1 represents, right? Similarly, if n2 will be, I have n walls in front of me and I am painting the nth wall with the second color. So what is the minimum cost that I need to paint the n walls, provided I'm painting the last wall with the corresponding color that is given by type, right? So let's talk about all the cases. So if n0 means we are painting the nth wall with the color 0, right? So what can we do with the n-1 walls? We can use color 1 and 2 only. We cannot use 0 again, because otherwise n-1 and n will have the same color. So it will be the minimum of, if n-1 1 comma, if n-2, sorry, n-1 n-1 2, the minimum that we get plus the cost of n2, sorry, n0, because we have painted with the 0th color, right? Jobathon, it is in a different channel. I think it is in GeeksforGeeks or something like that. It is in a different channel. Just maybe search on YouTube about Jobathon, you will get the videos. It's in a different channel, not this one. If n1, similarly, we have painted the nth wall with color 1. So what can we do with the first n-1, with the n-1th wall? We have to paint the first n-1 walls. What about the n-1th wall? We can just use color 0 and 2, because we cannot use 1 again. So we'll use 0 or we will use 2. And as we have painted it with color 1, so the cost n1 will be added. Similarly, if n2 mean, if n-1 0, if n-1 1 plus cost n2. So this is the recurrence that we get, right? If n0, n1, n2, what will be our final answer? Our final answer will be what? Our final answer will be the minimum of, we have to color the first n walls. The nth wall can be colored as 0. We have to color first n walls. Nth color can be colored as 1. Nth color wall can be colored as 2. This is our answer, right? And if 0 comma type will be 0, this is the base case. This is the recurrence. This is the answer to our problem. It's a very standard DP problem. I'm hoping that you already know about this. But if you have any doubts, let me know. I'll try to elaborate this a bit more. So let's quickly write the solution for this. In DP N3. Okay. N plus 1. Let's take N plus 1, because will be following 1 based indexing. So DP 0 0 equals to DP 0 1 equals to DP 0 2 equals to 0. Base case, right? So for int I equals to 1, I less than equal to n, I plus plus. So int dp I0, dp I0 is what? dp I0 will be minimum of dp I minus 1 1, dp I minus 1 2, plus cost or colors of I, and the zeroth color we are choosing, so it will be I minus 1, because the array is zero based index, right? And we are choosing a one based indexing, so that's why it will be sorry, dpi0 will be this. Similarly, dpi1, what will it be? It will be min dp I minus 1 0, dp I minus 1 2, plus colors I minus 1 1, and dp I2. We are just writing down the recursion in the loop, nothing else. Min dp I minus 1 0, dp I minus 1 1, plus colors I minus 1 2, and return. What will return? Will return the minimum of dp n0, or the minimum of dp n1, dp n2. This is what will return the answer to our problem. So let's try to run this. Any doubts with this? Pretty standard DP solution. So output is 10, and did we want 10 only? 10. Yes. So let's submit. Any doubts with this? This is a pretty standard DP solution. Anyone has any doubts with this? Or can we move to the next problem? Let me know if anyone has any doubts with this. I think during interview, recursion plus memorization, reference, and then tabulation. Any thoughts? I don't find any difference between like there is no difference between writing a iterative, like this is called tabulation, or iterative approach, and the recursive approach of DP. So whatever you are comfortable with, you can write that. I myself prefer iterative approach because of multiple reasons. First, it is much faster than a recursive approach. Secondly, it is like there is very less probability that it might run into some infinite loop or something. So in a recursive approach, you might actually face this problem that you have written some code, but it is running into infinite loop, so it is not executing or something. So again, like it completely depends on your personal preference. If you are comfortable writing recursive, just write recursive. If you're writing iterative, just write iterative. But again, like the way you come into this DP is same. You have to form the recurrence relation, and once you have formed the recurrence relation, once you have formed the recurrence relation, you can just write it in this way, right? You can just write the loop, and whatever you like, if you see whatever I have written here, right, was is the exact replica of the recurrence relation. Whatever I have written here is the exact replica of whatever I have written in the recurrence relation. Only n is replaced by I here, and everything is same, right? So it doesn't really like make any difference between a recurrence and the tabulation. In some cases, you might actually find recurrence to be more helpful, mostly when it comes to graph based dynamic programming, because the next states might not be like as simple as iterative traversal, right? But in case of arrays, it's generally like simple to write a iterative solution as well. Like the same thing, you will write it in recursive or iterative. In recursive, you will just like mark the base cases. You will just do something like this, that you will take a function int f, let's say int f. But again, like in recursive, you have to pass a lot of parameters, like you have to pass this colors array and everything. So vector of int. So iterative becomes much simpler here. So you pass the colors array, you pass the states, that is you are at nth element type, and these things you will pass, right? So finally, if n is equals to 0, then you will return 0. Similarly, if dpn type is not equals to -1. Let's say you initialize with -1, so you return dp n type, something like this. Otherwise you just write a recurrence like this, that dp n type is if colors n-1 that other types, right? So other types, something like this. If you see, this is the same thing that we are doing. It might be a bit simpler because you're writing the recurrence, so after that it might be simpler to do this, but again, like if you look into this, it is exactly the same thing that we are doing in the recurrence list. So once you're done with the recurrence, there is basically no difference between our recursive or our iterative. No worries. Let me know if you have any problems in this. So this is the dynamic programming solution. Now let's go to the last one. I believe John was really excited for this. Let's see how we can do this. But let me know if you have any problem with the previous question. Like if you need some more explanation around that, I'll definitely. Cake distribution problem. So problem is that Geek is organizing a birthday party, so his friends brought a cake for him. The cake consists of n chunks whose individual sweetness is represented by a sweetness. Now, at the time of distribution, Geek cuts the cake into +1 pieces to distribute amongst his gay friends. One piece he took for himself. Each piece consists of some consecutive chunks. He is very kind, so he left the piece with minimum sweetness for him. You need to find the maximum sweetness that Geek can get if he distributes the cake optimally. Right. So what he does is he will divide this cake. Each of this is a chunk. He will divide this cake into k+1 chunks, right? Like let's say these two form a chunk. We have to divide into two chunks, right? So these three can form a chunk. These three can form a chunk. Yes, exactly. Very good. Yes, book allocation problem. It is same as book allocation problem. Very good. Very good observation. So this is a chunk. This is a chunk, right? So you will only take continuous segment. Now what you have to do is you have to maximize the minimum sweetness, because Geek is taking the minimum sweetness, right? So you have to maximize the minimum sweetness possible after you divide it into k+1 k+1 chunks. So what you can do is exactly same as book allocation problem. First of all, let's prove that it is a monotonic sequence, right? So let's say we have fixed a length of the chunk, right? We have fixed a minimum sweetness x. We have fixed a minimum sweetness x, that is all the chunks that we create should have a sweetness greater than equal to x. All the chunks that we create should have a sweetness greater than equal to x. By this property we can find what is the number of chunks, what is the maximum number of chunks that we can get. How do we find? We will greedily allocate. Like let's say we have something like 632875, right? So 632875. Let's say we have fixed a minimum sweetness of 12. What is the answer here? Answer is 9. Okay, let's say we have fixed a minimum sweetness of 12, so all the chunks have sweetness greater than equal to 12. So let's see how we can allocate, how many chunks we can create. This will go to chunk 1, 6. 6 plus 3 is 9. Can we take it? Yes, we can take it. 9 plus 2 is 11. We can take it. And a chunk is not formed yet. 11 plus 8 is 19. So this is the first chunk that we formed. Let's start with the second chunk. 7. 7 plus 5 is 13. So we formed another chunk, 13. So we are able to form 2 chunks, but we need 3 chunks, right? We need 3 chunks because number of chunks we have to break it into is 3, k+1. So this is not a valid solution. So if you see, like if we think about it carefully, let's call px. What is px? Gx. Let's call gx. Let's have a function called gx. Let's define gx first. Gx, what is gx? The definition of gx will be what is the maximum number of chunks. maximum number of chunks we can get such that sweetness for each of them is greater than equal to x. Maximum number of chunks that we can get such that sweetness of each of them is greater than equal to x, right? So for example, G12 we found out 2, right? G12 we found out 2. Now what about Gx? Can we tell something about Gx? As x increases, what happens to Gx? As the sweetness required increases, we have to now take more of these chunks to form a bigger chunk to have this sweetness of x. So Gx, number of chunks that we can create out, will be decreasing. So Gx is decreasing. Similarly, when x is decreasing, that means the sweetness is decreasing. So let's say the sweetness decreases to 9. So earlier it was 12, we saw that we could create 2 chunks. Now with 9 we can actually create more than 2 chunks, because 6 plus 3, that is 9, this will be one chunk, 8 plus 2 will be one chunk, 7 plus 5 will be one chunk. So with 9, x decreasing, Gx is increasing. Number of chunks we can create will increase, right? Because now we have to take lesser number of individual chunks to form a bigger chunk, right? So this proves that Gx is monotonic. That initially Gx is more and finally it becomes less. So but we need k plus 1 chunks at least. So initially it will be more than k plus 1. For lower values of x, it will definitely be more than k plus 1. A point will come when it becomes less than k plus 1, right? And this is what we have to find. Right? This way x is increasing, the sweetness is increasing. So this is what we have to find. That is the maximum value of the, yes, maximum value of the minimum uh, uh, maximum value of the minimum sweetness. So we have to do this. So how can we do this? Just quickly, like we can now once we have this, we can just binary search for x, right? So we can have a predicate function px. Px will be Gx is greater than equal to k plus 1, because we need at least k plus 1 chunks. Now if p of mid is true, like we'll use our binary search technique. If p of mid is true, then high equals to mid, else low equals to mid, and we will make sure our high always points to a false. Sorry, if p of mid is false, then high equals to mid, else low equals to mid. So our low will always point to a true. The array will be like this: true, 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 true. After that, false, false, false. So our low will always point to a true, our high will always point to a false. So we have to find, we have to return low, right? And it will end at this step. So low less than high minus 1. So let's, I have already discussed this binary search approach multiple times. So just like if you haven't seen it, like there is a HD sheet as well available, and we have some binary search based problems there as well. So maybe you can look into the solutions for them. Like how do I how generally binary search has to be done in these. Right. Again, like there are multiple ways, whatever you feel comfortable with. So let's create a Gx int x vector int sweetness int right. So we'll num chunks equals to 0, and current sweetness equals to 0, right? So for int I equals to 0, or we can do like this: for int sweet belongs to sweetness, right? What we'll do is we'll do current sweetness plus equals to sweet. If current sweetness is greater than equal to x, what we'll do? We'll do num chunks. This will form a chunks, num chunks plus plus, and we'll set current sweetness to 0 again. So this is how we get the maximum number of chunks. So num chunks will return, and we will have a predicate function. So bool predicate, int x, vector int sweetness, int k, and will return gx comma sweetness greater than equal to k plus 1, right? So that is the condition. So initially what will start with, the low will be the minimum value. So low will be the value at mean element, sweetness dot begin, sweetness dot end. Int high will be what? High will be accumulate, that is the sum of all the elements. That is at best case we can just have one chunk, right? When key is 0, so accumulate sweetness dot begin. Accumulate will find the sum of all the elements, right? Sweetness dot end, and initially it will be 0, right? What is k? What is the minimum value of k possible? So k can be 0, right? K can be 0, so high can be a possible solution. So we'll check first if high is the possible solution. So if p of high, sweetness, and k, then in that case low equals to high, we'll just set low equals to high, right? Otherwise we'll go for the loop while low less than high minus 1. Int mid equals to low plus high by 2. If p of mid, sweetness, k, if it is true, then low equals to mid, else high equals to mid, and finally we'll return low. So this is the code. Let's run this. Let me know if you have any doubts. So it is giving a 9, which is correct, I believe. Yeah. So this also works. Let me know if you have any doubts with this. Anyone has any doubts with the logic or anything? So by the way, I'm not sure, but again, like Geeks4Geeks has created a institution. I'm creating like me and Ayush are creating the videos for there. So there's a lot of problems, like around 230, 200 plus or 300 plus problems. So we'll be creating videos for all of them. The video of a few segments are already out, so you can check them out and you can definitely solve the problems. Let me know if you have any doubts with this. Anyone has any doubts with this? Any doubt with any question? Which one in detail? With which one in detail? Which one do you need in detail? Let me know. One. Okay, last one. All right. Let's understand this again. Do you understand Hindi? Shall I speak in Hindi? Like if that will help you somehow? Let's write down the example. Awesome. Let's understand this, right? Let's first of all forget about the problem, right? Whatever the problem demands, problem जो भी बोल रहा है, let's forget about that right now. Let's focus on another problem जो है कि gx, right? What is gx? Gx ये है कि all the chunks. What is the maximum number of chunks, right? What is the maximum number of chunks that you can have where each chunk has sweetness greater than equal to x? इसका मतलब है कि how many chunks that you can create, what is the maximum number of chunks that you can create such that हर एक chunk का sweetness is greater than x. फॉर एग्जाम्पल मान लो G12 का मतलब क्या है कि कितना चंक्स मैं कर बना सकता हूं फ्रॉम दिस सच दैट हर चंक का स्वीटनेस 12 से ज्यादा हो. तो हाउ कैन आई डू दैट? सी 6 3 2, what is 6 plus 3 plus 2? 11. So it is less than 12, right? So this will form an entire chunk. 6 plus 3 plus 2 plus 8, this will form a chunk because ये चंक का स्वीटनेस ग्रेटर देन 12 होगा. एंड वी हैव टू चूज कॉन्टिन्यूअस सेगमेंट्स एज वेल. ये भी लिखा है कि इधर कंसेक्यूटिव चंक्स लेकर ही चंक बना सकते हैं, राइट? सो वी कैन चूज ओनली कंसेक्यूटिव सेगमेंट्स. सेकेंड पार्ट में और दूसरा चंक ये बनेगा 13 का. सो वी कैन मेक 2 चंक्स G12 का. व्हाट अबाउट G9? व्हाट अबाउट G9? G9 का मतलब क्या है? फिर से अगेन, व्हाट इज द मैक्सिमम नंबर ऑफ चंक्स दैट वी कैन क्रिएट such that हर एक चंक का स्वीटनेस ग्रेटर देन 9 हो. हर चंक का स्वीटनेस विल बी ग्रेटर देन 9. हाउ कैन वी जनरेट? सी 6 plus 3 9. तो ये एक चंक बन सकता है. 6 plus 3 9, ग्रेटर देन इक्वल टू 9 करना है बस. 8 plus 2 10, ये एक चंक बन जाएगा. 7 plus 5 12, ये एक चंक बन जाएगा. So we can have 3 chunks G of 9. We can have 3 chunks, right? Similarly G of 20 मान लो. G of 20 में 1 चंक रहेगा most probably like 6 9 10 11 12 13 14 15 19 plus 7. तो एक ही चंक बनेगा. G of 20 में एक ही चंक बनेगा. We cannot have 2 chunks. So that is the definition of G. ये क्लियर है? ये बताओ, ये क्लियर है सबको? The definition of G is clear with everyone? Is the definition of G clear with everyone? Okay, awesome. G का तो definition clear है, right? What is the property that we saw? मतलब अगर हम लोग फिर से देखेंगे, फिर से लिखेंगे G13 was 2, G9 was 3, G20 was 1. प्रॉपर्टी एक दिख रहा है, राइट? इसको हम और जनरली प्रूफ करेंगे. बट जब x इज इंक्रीजिंग, gx इज डिक्रीजिंग. ये हमको एग्जाम्पल से तो दिख रहा है, राइट? एग्जाम्पल से तो दिख रहा है x इंक्रीज हो रहा है, gx डिक्रीज हो रहा है. How can we formally prove this? Think about it. When x increases, what is the meaning of increasing x? We want to have more sweetness. That is, we might need to add more cakes to a chunk. We might need to add, मतलब 9 से जब 13 गया तो we had these 3, right? 9 से जब 12 गया we had these 3 for 9. तब हमको और एक एक्स्ट्रा ऐड करना पड़ा. या वी हैड दीज 2 for 9 बट वी हैड टू ऐड दीज 2 एक्स्ट्रा. सो व्हेन x इज इंक्रीजिंग we have to add more cakes. So definitely the number of cakes is limited, right? Number of cakes is n that is given to us. So the number of chunks will be decreasing as x is increasing. Gx will be decreasing, that is the number of chunks will be decreasing. Similarly, when x is decreasing, दैट इज व्हेन x इज रिड्यूसिंग, जब मान लो हमको कम स्वीटनेस चाहिए, हर चंक पे हमको कम स्वीटनेस चाहिए, तो लेट्स से gx x is 6, right? So we can just have this as a chunk, 3 4 5, these three as a chunk. Again, we can have this as a chunk, or these two as a chunk, something like that. Let's say x is 5, so we can also like maybe further reduce the number, increase the number of chunks. Sorry, how to, we have to further, we can further increase the number of chunks. X is 5, so this can create a chunk, these two can create a chunk, this can create a chunk, this can create a chunk, this can create a chunk. So when x is decreasing, the number of chunks is increasing, because now we require less sweetness per chunk, so we can take less number of cakes per chunk, so the number of chunks is increasing, so gx is increasing. Does this make sense? This part is making sense, right? X is increasing, gx will be decreasing. जितना x बढ़ेगा gx घटेगा, जितना x घटेगा gx बढ़ेगा. Does this make sense? Does this make sense? Gx is monotonic with respect to x. If we plot a graph of x versus gx, it will be decreasing like this with x. Does this make sense? Is it making sense? Yes या no? बता दो चैट पे. कुछ डाउट है तो बताओ. ओके, चलो सेंस बन रहा है, राइट? राइट. अब हम लोग और एक फंक्शन डिफाइन करेंगे, px. px का क्या मतलब है कि gx क्या दे रहा है? gx is giving the maximum number of chunks that we can generate, but right, but we have to at least generate k plus 1 chunks, क्योंकि k फ्रेंड्स है प्लस geek को भी खाना है, so we have to at least generate k plus 1 chunks. So gx should be greater than equal to k plus 1. that is a constraint that we have, क्योंकि हमको k plus 1 chunk से ज्यादा बनाना ही है, राइट? तो इसका मतलब क्या हुआ कि फिर से अगर ग्राफ देखेंगे, राइट, अगर फिर से ग्राफ देखेंगे gx वर्सेस px का, सॉरी gx का, x डिक्रीजिंग था, so it is decreasing, right? Initially number of cakes, number of chunks we can generate is a lot, right? It is definitely greater than k plus 1. It is decreasing slightly. A point will come where it becomes equal to k plus 1, and after that it becomes, or it is becoming greater than k plus 1. The next point will be less than k plus 1. So ये points तो पूरा valid नहीं है. These points are valid points, right? These points are not valid. These points are valid. We want k plus 1 k chunks at least. This means that if we look into the px graph, if we look into px array, if we think that we can generate an array on px, how will the px array would look like? For initial values of x, it will be true, because px will be greater, gx will be greater than equal to k plus 1. A point will come when it becomes false, because we cannot generate k plus 1 chunks. So now we have to find this occurrence of true, the last occurrence of true, and that is the maximum possible minimum value. That is the maximum possible minimum value, right? So these are possible, but this is the maximum possible out of them. So we want to return this. So in this, we know how to do a binary search. We just have to do a binary search and figure this point out. What is this point? So that is exactly what I've done. This is how we can do the binary search. This is the binary search that we have done. And we have figured out the, or you can do it in different way as well. There are multiple ways to find this first occurrence of true. Any more doubts on this? In case if you don't have any doubts, let's end the stream here today then. Thank you guys for joining in, and I'll be seeing you in the next